Welcome to the channel. To continue our discussion on the testing of speedometers, we shall today be talking about odometer tamper resistance and verification. Our discussion would include odometer tamper resistance and verification in general, its objectives, key test aspects, glossary of some important key terms, infographics, how this applies to analog versus digital speedometers, real-world tamper resistance test case with reference to digital speedometer, odometer verification and checklist, filled out odometer tamper resistance test reports, and printable field inspection checklist templates. And finally, introduction to the next topic. As you might be knowing, odometer tamper resistance and verification is a critical safety and regulatory concern for automobiles, motorcycles, cars, and other vehicles, as odometers are tied to resale value, maintenance intervals, and even insurance premiums. Let us break it down thoroughly for both analog and digital speedometers. What is odometer tampering? Odometer tampering refers to manipulating the recorded mileage to display a lower distance than the motorcycle has actually traveled. It is a form of fraud and, of course, illegal in most of the countries. Tamper resistance ensure the odometer is designed in such a way that it cannot be easily altered without detection. Verification means check the odometer accurately records distance over time and retains data integrity even under tampering attempts or power loss. Key testing aspects include number one, distance accuracy. That is, validate correct distance recording within tolerance of usually plus minus 2%. Number two, memory protection. Test whether data stored in EEPROM oblique flash can be altered or erased. Power loss test. Simulate battery disconnect. Verify speedometer retains correct reading. Backfeeding test means inject voltage through diagnostic port to test if the memory can be modified. Tamper detection. System should detect and log unauthorized modification attempts in digital. Physical access control. Check if mechanical or PCB level access can reset mileage. CN bus CAN bus interference. For digital, try spoofing signals to alter odometer readings. Now, explanation of some key terminologies used in this discussion. CAN bus interference, that is control area network Bus interference refers to unauthorized or malicious access or disturbance of the vehicle's communication system. The CAN box is the system that allows microcontrollers and devices in a car like speedometer, engine control unit, ABS, airbags, etc. to communicate with each other without a host computer. Interference occurs when someone from outside injects faulty data, disrupts signals, or manipulates communication over the CAN bus to alter displayed information such as vehicle speed, odometer readings, or other sensor data. It is relevant to speedometer because a tamper might send fake speed data or block genuine signals to deceive the speedometer. CAN bus interference is one of the most common non-invasive electronic methods used to falsify speed or mileage readings. B. Spoofing signals. Spoofing signals refers to creating and sending fake signals or data to trick a system into accepting false information as legitimate. In the context of speedometer testing or tampering, spoofing involves generating counterfeit sensor signal, that is, wheel speed, GPS speed, vehicle speed, sensor signals. Those spoofed signals mimic legitimate data but are designed to mislead the speedometer or data loggers. It is relevant to the speedometer as a tamperer may spoof signals from the speed sensor to make the car appear as if it is running slower or faster than it actually is. Used in the lab or test rig manipulations, spoofing can also deceive fleet monitoring system, insurance telematics, or regulatory test devices. Therefore, CAN bus interference means unauthorized disruptions or manipulation of the car's internal data network. That is, inject fake or altered speed oblique mileage data via car's communication system. And spoofing signals mean fake signal generated to mimic real sensor output. Simulates wheel speed or GPS data to deceive the speedometer or test systems. ECU, that is engine control unit. It is a computer of your vehicle. It controls and monitors many things like engine performance, speed, fuel use, and many more. It receives signals from sensors like speed sensors and sends commands to various parts of the vehicle like the speedometer. In tampering cases, people may try to trick the ECU or feed it false signals. EEPROM, that is electrically erasable programmable read-only memory. EEPROM is a small memory chip inside the engine control unit or the instrument clusters. It stores important long-term data such as odometer mileage, calibration data, and service history flags. In tampering, people try to reprogram or rewrite the EEPROM to reduce mileage, for example, to falsify increase resale value. Non-invasive method means tampering without opening up or physically damaging the parts. For example, using a diagnostic port to inject false data, using software tools to change readings. It is like hacking into a system without breaking it open, less risky and harder to detect. To mimic means to copy or imitate something so that it looks or acts like the original. In tampering, devices may mimic a speed sensor, creating fake signals that the system accepts as real. These signals fool the ECU or speedometer into showing incorrect speed or mileage. Insurance telematics refers to as the telematic is the use of GPS and data system to track a vehicle's behaviors. Insurance companies use telematics to monitor speed, braking, acceleration, time of driving, etc. Offer usage-based insurance. Good drivers get lower rates of insurance. If tempered, the data can be faked to make a driver appear safer than they really are. Here is the Here are infographics related to tampering of speedometer and verification test. How this applies to analog versus digital speedometers? While considering analog speedometer, number one aspect is design. Uses gears and rotating drums driven by a cable from the wheel or gearbox. Tampering rates. High, easy to roll back using a drill or manual gear manipulation. Tamper resistance. It is low, little, or no security unless sealed inside speedometer housing. Verification methods. Visual inspection of gear damage or mismatch. Compare mileage with service history, tire wear, etc. Security enhancement aspects. Tamper-proof seals, security screws, odometer replacement records. Summary. Analog odometers are vulnerable unless physically adequately sealed and monitored via service records. How this applies to digital speedometers. Design aspect uses vehicle speed sensor, that is VSS, plus microcontroller to calculate and store distance in non-volatile memory, that is EEPROM or flash. Its tampering risk is medium to high via diagnostic ports or by reprogramming EEPROM chips. Tamper resistance is high if secured. Modern engine control unit use encryptions, locked memory, and CRC checksums. Verification methods include odometer versus ECU mileage comparison, check CAN logs, look for EEPROM rewrites events. Security enhancement. Checksum are digital signature, increment-only counters, secure boots, locked EEPROM, event log stored in ECU. Summary: digital odometers can be well protected, but they require encryption, firmware, safeguards, and diagnostic tracking. Now coming to rear-word tamper resistance test case. Here, a digital speedometer. Test setup, for example, the type and brand of digital speedometer, power source 12-volt DC supply, distance simulation pulse generator mimicking VSS signals, attack vectors EEPROM programmer, and OPD spoofing tool. Test action includes simulate normal rate ride, say 5 km, and expected result is odometer increase by 5 kilometers. Disconnect battery and reconnect. The expected result is no mileage lost or reset. Attempt EEPROM override. EEPROM access is blocked or checksum fails. Send false CAN data or fake speed. System discards unauthorized inputs. Compare mileage with ECU backup. It must match. Common digital anti-tamper measures. Feature: write once memory sectors. Odometer segments that cannot be rewritten once set. Checksum or hash verification. It detects altered EEPROM values. Redundant recording ECU plus cluster. Description: stores mileage in multiple modules to cross-verify. Event logging logs any odometer reprogramming attempt. Security access levels prevents unauthorized access via diagnostic tools. So the checklist is: number one, visual signals of tampering, scratches, broken seal, analog, digital. Suppose it is not. There is no visual sign of tampering. So it is okay in both the cases, that is analog and digital. Compare mileage with service history and record the data and check it accordingly. Number three, match speedo mileage with ECU or diagnostic tool. Look for sign of EEPROM replacement. Run canvas log or dump for odometer related events. Inspect solder joints or access port on Speedo PCB. Check diagnostic tamper log if supported. So applying both analog and digital speedometers, record the result and check it accordingly. Summary of vulnerability. In case of analog, tamper resistance is low, needs testing, yes. Secure the design, no. In case of digital speedometers, tamper resistance is medium to high, needs testing, yes, it needs testing. Secure by design, yes, if it is designed properly. Now We come to a filled out odometer tamper resistant test reports for a digital motorcycle speedometers, a printable field inspection checklist template for workshops or road authorities. Filled out test report example include test subjects, Harley-Davidson Road Glide, odometer type, ECU storage, tester, that is EMC or diagnostic team, and or QA lab, date 15th May 2025. Test setup. Summary. Pulse generator. Simulated speed pulses from 0 to under kilometer per hour. CAN bus monitor. Power vision diagnostic tool. EEPROM access attempted with CI341A plus dumb utility. Tool use power supply emulator, oscilloscope, CAN stamper, and multimeter. Test procedure and results. Simulate ride 10 km. Odometer, in this case, odometer should increase by 10 km. Result, if 10 km added, then it is declared as pass. Stable reading. Power cycle disconnected. Power cycle disconnected battery. There is no mileage loss observed. Retained the speedometer retained its value. Therefore, it is declared as pass. Attempt EEPROM write via header access should be rejected or invalidated. CRC mismatch odometer reset to safe mode, so it is declared as pass. That is, EEPROM is fully protected. Inject false speed via CAN spoof should be ignored by the system. If it is ignored, the speedometer is considered as passed. It is fully protected against tampering. Compare ECU versus instrument clusters. Values must match. Both shows the actual and correct values. For example, 21,505 kilometer. Therefore, it is passed as a mirror copy is verified. ESD shock on housing. No data corruption is observed. The data is displayed. Display flicker data is inflect. It is declared as pass. Attempt backfeeding voltage via OBD2 should not alter mileage, as it does not alter the mileage, so there is no effect on the system. So the odometer of the speedometer is considered as pass, as OBD is fully protected. Overall result, odometer is tamper resistant per test plan and ISO 26262 digital integrity standards. You can use these checklists at inspection centers, service workshops, pre-owned motorcycle evaluations, RTO DMV verifications, including make, model of the motorcycle, vehicle identification chases, speedometer type, whatever it is, mileage displayed in kilometers. Visual inspection, speedometer or odometer. Speedometer housing is intact. No tool marks are observed. Screw and seals on speedometers appear original. No tampering attempts were made. Consistent wear versus mileage claim. Service history matches mileage trend. In case everything is okay, the odometer or speedometer is considered as pass. For the digital check system, if applicable, Odometer matches ECU mileage via scan tool. If it matches, it is pass. No tamper logs or writing attempts detected. If it is so, it is pass. No data mismatch between modules, that is cluster versus engine control units. If it matches properly, it is considered as pass. Scan log shows no spoof speed signals, considered as pass. Odometer increments under test ride. If it is okay, it is considered as pass. And finally, inspector signature and date of signature. With this, we conclude our today's discussions on odometer tamper verification, odometer tampering testing, and verification. Our next topic related to this series is lighting and display legibility testing. Thank you and thank you very much.